Hello everyone, my name is Kabir and today I'm going to present on the topic requirements for virtualization. In contrast to real machines, an individual must be able to boot and run different operating systems on virtual machines, like what can be done on the hardware as well. It is the task of the hypervisor to do so. You can think of hypervisor as a virtual machine monitor or VNM, which is basically a software that creates and runs virtual machines. Overall, hypervisors should score well in three dimensions. The first one is safety, in which hypervisor should have command on all the virtualized resources. The second one is fidelity. The behavior of a program on a virtual machine should be similar to the program running on the bare hardware. And the third one is efficiency. The code running on the virtual machine must run with any interference of the hypervisor. Some of the instructions can be executed directly, but they cannot be executed all at once. And to add to this, the fastest way and safest way to execute the instructions is via interpreter, where it evaluates each and every instruction in turns. Per se, the simple instructions like increment can be executed by the interpreter, but unsafe instructions like the foreign operations modifying the operating systems must be simulated first. In conclusion, interpreter is safe but lacks in the performance area. Now talking about the fidelity, it is evident that due to defects in the Intel 386 architecture, virtualization had its issues, which was referred to as backward compatibility. In short, different instructions in kernel and user mode behave differently when executed in either kernel mode or the user mode. These instructions perform tasks such as input-output, modifying the memory management unit settings, etc., and are called as sensitive instructions, according to Popek and Goldberg. There is also a group of instructions which, if executed in user mode, can trap, and they are called as privileged instructions. A lot of sensitive 386 instructions were ignored if they were to be executed in user mode. For example, the flags register is replaced by POPF instruction, which changes the bit that allows or disable interrupts. As a result, 386 and its successors couldn't support a hypervisor, and they couldn't be virtualized. Some more dangerous instructions can even read sensitive information in user mode. Like on the 86 architecture processor, a program could easily determine the mode of the program by just reading and interpreting the code segment selector. It can then cause an operating system to make wrong decisions based on these in this wrong information. So what can be done about this? A solution was proposed to this problem by finally introducing the concept of virtualization in the CPUs starting in 2005 by Intel and AMD. It was called as virtualization technology on the Intel CPU and secure virtual machine on the AMD CPU. Both technologies were inspired by IBM Virtual Machine 370, but of course with some slight difference. The virtual machines were made to run in containers, and when a guest operating system is started in a container, it stays there until an error occurs and the hypervisor is notified. And basically, what we call as is trap and evaluate virtual machine approach became possible with these extensions. But on the one hand, it was mentioned that the 86 architecture was not able to virtualize until the 2005 architecture modifications. And in 1999, VMware, on the other hand, released its first 86 hypervisor. So this begs the question that how can this be true at the same time? Okay, so the answer is very simple. Before 2005, hypervisors didn't really run the guest operating system, but rather rewrote just a part of the code to replace the faulty part of the instructions with safe code sequences that evaluated the original instructions. For example, if the guest operating system modifies the CPU's privileged control registers, then it is important to know the implications of such instructions are restricted to only virtual machines and have no effect on other virtual machines or the hypervisor. Thus, trap was introduced just before an unsafe input-output instruction was executed, and after a brief safety check, and we came to know that an equivalent instruction can be performed, and we get a positive result in return. Another advantage of rewriting instruction is that it allows us to replace instructions that are sensitive but not privileged, and this is referred to as binary translation. Okay, so another type of virtualization is also known as para-virtualization. According to Techopedia, para-virtualization is a virtualization technique that provides an interface to virtual machines that are similar to their underlying hardware. In contrast to full virtualization, it is very different and it represents a machine-like software interface that explicitly exposes the fact that it is a virtualized environment. It consists of something called as hypercalls, which enables the guest to explicitly send requests to the hypervisor. Guests mainly use hypercells for important operations, and since they are performed explicitly, so the overall system is much simpler and faster. It should also be noted that para-virtualization was already offered in IBM's VM operating systems back in 1972. Now, one of the major drawback of para-virtualization is that the guest should be aware of the virtual machine API, and therefore it should be customized explicitly for the hypervisor. Thank you, everyone.